morning, and first of all, let me thank the organizer to give me the opportunity to be here in this wonderful place and attending this exciting conference. And I'm here to talk about probiotic and their role in aquaculture. Okay. All of us well know that aquaculture production during the past decades increased increased a lot during the past decades, but this increase was related mainly to the tons of fish produced and not to the number of fish produced, because we know exactly that only 20 most produced species account for more than 80% of production. It means that we are increasing in the production, in ton production of fish, but we are not increasing the number of farmed fish. And this limitation is due to reproduction, mainly due to a reproduction impairment. Because we have it's not so useful to have the presentation behind. And broodstock management should ensure during the farming production that the species could reach the reproductive maturation. The species could spawn, so ovulate, so produce gametes and quality gametes. This is the main problem of the reproduction of farmed species reproduction. We have a lot of problem on producing gametes, producing egg and sperms, and in particular good gametes, good egg and good sperm. Before to entering in the role of the probiotic on solve the reproductive problems, I should introduce the reproductive control, how the reproduction should works normally. And reproduction in fish is controlled by three major glands: the hypothalamus, the pituitary, and the gonads. And all these three glands represent the hypothalamus-hypophysis-gonads axis. During this axis are produced several hormones. The reproduction control starts from the hypothalamus. Hypothalamus is the main gland which can accept stimuli from the external stimuli, such as temperature, such as salinity, and such as light, the photoperiods, but also the internal stimuli, including the metabolic state of the species, of the animals. The hypothalamus, integrating all these stimuli, internal and external stimuli, produce an hormone, the GnRH, which in turn induce the hypothalamus to produce another hormones, the gonadotropins hormones. The gonadotropins hormones reach the gonads. To stimulate the steroidogenesis, the production of additional hormones, and finally the gametogenesis. I am a reproductive biologist, and I'm mainly focused on female reproduction. The gametogenesis of female reproduction is known as oogenesis. This is a process during which immature oocytes Okay, an immature oocyte becomes a mature oocyte, a mature eggs, and the oogenesis is represented by 3 different main steps. The first one is the vitellogenesis, the second one was the maturation, and the third one was the ovulation, the spawning. All these three stages represent the major impairment of reproduction on farming species, on farmed species. So, about which are the the reproductive dysfunction of farmed species, which are our challenge. First of all, the first impairment was related to vitellogenesis, the first step of oogenesis. This is the most high problem for farmed species. Okay. Sorry, I see. Here is better. This problem is typical of anguilla here, anguilla species, and for a Mediterranean amberjack, and how we can evaluate if our farm species have a problem related to vitellogenic phases. We have a lot of tools to evaluate it. We have several reproductive index, including the gonadosomatic index. We can do histological analysis of the gonads to evaluate if the vitellogenesis is compromised, and we can do a lot of biochemical analysis to evaluate the composition of the yolk. A good egg should have a good composition on lipids, carbohydrate, phosphate. So it is important to monitor these compounds, and for sure we can evaluate the expression of genes related to vitellogenic. So we have a lot of tools to monitor the vitellogenesis phase for a farmed species. The second dysfunction is the maturation dysfunction, so the second step of the oogenesis. This is the most common type of dysfunction which we encountered on farmed species. Also for this impairment, we have several tools to monitor this impairment. In particular, we can do in vitro maturation assay. We can do once again histological analysis to evaluate the number, the percentage of mature oocytes, and once again we can evaluate the gene expression of gene related to which control the maturation phase. The last reproductive dysfunction is related to the spawning, to the ovulation, to the release of the eggs, and the farmed fish have to release the eggs, but good eggs. And also for this impairment, we have several tools to evaluate this dysfunction, and we have a lot of reproductive index, which are, for example, the number of the eggs, the fecundity rate, the fertilization rate, the hatching rate, and the deformity rate of the larvae. The impairment are related not only to female, but also to males. And regarding the males, we have two main dysfunction of the reproduction. We can have the malformation, the spermatozoa malformated, so not functioning, and or with a wrong motility. The spermatozoa to be functioning, it should have a good motility to reach the oocyte to do fertilization. So these are the two main problems on farmed species reproduction males. We have a lot of strategies to try to solve the reproductive impairment. First of all, we can collecting juveniles or adults directly from the wild. Is the best practice, is the zero consuming strategies, but is not so much sustainable. And we know that is unreliable and unpredictable. So is the is not so good like solving strategies. Another strategy is manipulating the environmental parameters. As I said, the hypothalamus is controlled by external stimuli, light, temperature, so we can manage changing these environmental parameters to increase the reproductive capacities of farmed fishes. And the last strategies that we already have available to solve the reproductive injuries is the hormonal treatments. Also in this case is not so sustainable because the hormonal treatment is so hard and can interfere with other biological process of the fish. So also these strategies is not so good. This is why 20 years ago, more or less, some researchers started to treat the broodstock, the reproductive, the broodstock, sorry, both female and all of us know who are the probiotics. Probiotics are live microorganisms that have the opportunity to confer beneficial effects to the host. But which are these beneficial effects? Are so many. First of all, we use the probiotic for disease control as a growth promoter, for improve the digestion, improve the immune system. The probiotic was used as source of nutrients to improve water quality, and last but not the least, to promote reproduction. The treatment of probiotic, the analysis of the use of probiotic as a reproductive promoter started, as I said, more or less 20 years ago on ornamental fish. These are all the species used in several treatments using probiotic as a promoter of the reproduction. Most of the results have been achieved on zebrafish. Zebrafish is an experimental model, so for sure a lot of studies and papers are available for this species. What I want to focus that in all these species, most of the species, the effects were evaluated only. Okay, thank you. Were evaluated only on females, and the analysis of the reproductive improvement by probiotics on male. Okay. Have been conducted only on zebrafish and on carassius. In all the other species, the Xiphophorus and Pecilia species are evaluated only the female reproduction. We start with zebrafish. the focus, the treatment of probiotic to improve zebrafish reproduction was the focus of my PhD. So for me, it's an important focus. And we have a lot of papers, we have a lot of different treatment made on zebrafish with different probiotic strain and with different time exposure. What we know by these studies, we know that probiotic, all the treated probiotic, all the used probiotic, Lactobacillus rhamnosus, 2 different strains, Lactobacillus casei, have impressive effects on zebrafish reproduction because these probiotic interact with the brain pituitary gonadal axis, so improve the expression of the hormones, all the hormones that are produced during the by this axis to produce final good oocyte. We know that probiotic have effects on the vitellogenesis phase, and we saw these effects by histological analysis, by evaluating reproductive index, because after probiotic administration, the gonadosomatic index increased, the number of vitellogenic oocyte increased, and increased also the expression level of gene related to vitellogenesis. We performed also an analysis on the quality of the yolk proteins included in the oocyte after probiotic administration, and we found that these oocytes have a different proteic pattern, but not only change the protein contents, but also the lipids, the carbohydrate and phosphate contents, because we applied also an infrared microspectroscopy analysis to achieve all the macromolecular building of the oocyte. So we evaluated also the last phase of the oogenesis, the oocyte maturation. And we saw that the administration of probiotic induced in vitro the in vitro maturation of the oocyte. And finally, we saw that the probiotic have a great effects also in the final stage of the reproduction, the spawning, because the females treated with probiotic release more and more a higher number of eggs, and also the hatching rate is better than the control one. On zebrafish, other colleagues from the Spain University evaluated also the effects on spermatogenesis, and they saw that probiotic can improve spermatogenesis by increasing the number of fluent males, increasing the sperm concentration, total motility, progressive motility, and fast spermatozoa subpopulation. The other species in which was evaluated the spermatogenesis was the Carassius. In this species, the authors utilized the Pediococcus acidilactis for 180 days, and we saw that this treatment increased the sperm concentration, the sperm motility, and the sperm duration. In the other ornamental fishes, the analysis was performed only on females and only by using 2 different kind of probiotic and for different time of exposure. And the authors saw the same results. An increased vitellogenesis because fishes treated with probiotic showed an increase, higher gonadosomatic index, and also have positive effects on spawning because the treated species, treated females, presented a higher fecundity, fry survival rate, and a reduced fry deformity rate. These are all the results obtained on ornamental fish. What about farmed commercial fish. We have nowadays several studies conducted on different farmed species, but I want to remark by now that the studies are conducted only on freshwater species, and only one anadromous, the salmon, and only one catadromous, the eel, but we lack completely marine species. But first of all, the application of probiotic on reproduction was done on tilapia. Tilapia is the one of the most farmed species all over the world, and this species was used to evaluate the probiotic effects on both female and both male, and using different probiotic strain, but the authors obtained the same results: an increase of vitellogenesis and the spawning, and an increase of the spermatogenesis. So also in tilapia, the probiotic administration increased the reproductive performance of both male and female. We have several trials on tilapia. The second step of trials on tilapia was to give the probiotic via water. The first study was the probiotic was administered in the food. In the second trial, the probiotics was administered in the water, but the author obtained the same results. Also in this case, the spawning was increased, the number of eggs, the total number of fry. And this second trial is interesting because the authors not only give the probiotic in the water, but also done an economic an economic analysis, and from their economic analysis they evidenced that the use of probiotic to enhance reproduction has economic advantages because they analyzed the total feed consumption, the total probiotic consumption, the total cost of feed of probiotic, the number of fry, the number of all the costs related to this farming, and finally the authors found that the treatment of probiotic has economic advantages. The second species of tilapia, which was used as probiotic to enhance reproduction, is the red tilapia, the hybrid between Neurochromis niloticus and Neurochromis mozambicus. And also in this case, the treatment was done on both male and females. And also in this case, the results are once again good results, because the probiotic treatment induced the vitellogenesis phase, and in this case the authors applied hormonal levels analysis, performed histological analysis, and also gene expression analysis. All the results indicate that probiotic can improve vitellogenesis phase and also can improve spermatogenesis by improving the quality of sperm. Once again, they applied hormonal levels evaluation, histological analysis, and the gene expression related to spermatogenesis. And all the results obtained evidence that probiotic could have a positive effect on spermatogenesis. This is another species farmed mainly in Brazil, said Matrinxa, the Bricon amazonicus, and in this case the authors treated the farmed fish for 9 months, and finally they evaluated an increase on spawning. So they found an increase of number of eggs produced, a fertilization rate, and hatching rate. Another species, freshwater species, was the catfish, the African catfish. In this case, they treated the fish for 12 weeks, and they obtained once again good results. They obtained an increased vitellogenesis and maturation, and they obtained also an increase on the spawning by evaluating all vitellogenesis, maturation, and spawning using reproductive index, macroscopic index. Another freshwater species is the silver barb. The silver barb was treated with, in this case, is interesting because they treated with single probiotic and with all the probiotics together, and they obtained several interesting results, but the main results say that the combination of the probiotic is the best way to improve the reproduction on this species, because they obtain good results also using single probiotic, but the best results obtained were when the fish were fed with the combination of all the probiotics. And in this case, they obtained an increased vitellogenesis and maturation, and also an increasing spawning. The last freshwater fish is the rainbow trout. Also, the rainbow trout is one of the most species farmed, mainly in Europe, and come from Italy. So the rainbow trout is a typical species farmed also in Italy. And also on rainbow trout, we have available several papers, several treatments with different probiotic and for different time of exposure. The first study was done on males by 20 weeks of exposure with a combination of bacterial, of 8 bacterial, and the authors obtained an improved spermatogenesis by evaluating the semen, the semen quality. They found an increased sperm concentration, the semen volume, and the total motility. So the treatment of rainbow trout males with this bioaqua was done good results. A second work, 3 different works were made also on females, and the results obtained are once again good results. All the probiotic administered were administered for 8 weeks, and at the end of the treatment, the vitellogenesis and the maturation, the spawning were significantly increased. This is the results obtained on salmon salar. Salmon salar was treated only for male analysis, and in this case the author obtained once again good results on spermatogenesis improvement by analyzing the reproductive index, by analyzing the semen quality, and by analyzing the fertilization rate and the hatching rate. The last farmed species is the anguilla, the eel, and also this is a very important from our economical point of view farmed species. And once again, this species was treated with probiotic for 3 weeks, and the analysis were performed only on males. But the authors once again obtained positive effects on the spermatogenesis by analyzing the semen quality and the expression of gene related to spermatogenesis. So it seems that probiotics have a good, positive role on improvement of reproduction of farmed species. But now the farmed species are facing new challenges because the farmed species are facing climate changes and pollution. And all these are, can be defined as environmental stressors. Who are the environmental stressors? Environmental stressors can be chemical stressors, the pollutants. We have several kind of pollutants, chemical fertilizer, chemical waste from industry, insecticides, herbicides, fungicides. So we have a lot of different kind of pollutants. We have also physical stressor, including the temperature, including the light, including the salinity. So also in this case, the farmed species are facing several challenges. And what we know by now, that all these environmental stressors could impair reproduction. It could impair reproduction both in male and in female. So now we are in this case. We know that we are facing climate changes and pollution, and we know that climate changes and pollution can impair reproduction. So we now have to develop new strategies to mitigate the negative effects of such stressor. And some authors suggested the use of probiotic. We know that probiotic improve reproduction. We know that environmental stressor can induce a decrease of reproductive success. So this author try to understand the possible mitigative role of probiotic on the effects of environmental stressor. The first study was done on zebrafish. All the studies were done on zebrafish because it's easy to work with zebrafish. And the first studies focused on the effects of bisphenol A. Bisphenol A is an ubiquitous pollutant, is an endocrine disrupting pollutant because this is the chemical formula of the BPA, of bisphenol A, and it mimics estradiol, which is an reproductive hormone. So when a fish is in the presence of bisphenol A, it's like the fish is in the presence of estradiol. And BPA is used for the production of polycarbonate plastic, and we found BPA on water bottles, on toys of our children, on epoxy resin. So we find BPA all over the world. And we know that BPA can impair reproduction, both male and female reproduction. So the authors exposed the zebrafish to the BPA and to the BPA with the probiotic. And they saw clear results. They obtained clear results on spermatogenesis. The treatment with probiotic and BPA seems to mitigate the negative effect of BPA. So when the probiotic is administered with the BPA, the spermatogenesis is completely recovered. The males recover the percentage of spermatozoa and all the levels of gene related to spermatogenesis. So in males, the authors obtained clear results, but in females, not yet, because the co-treatment of BPA with probiotic gives similar results of the BPA alone. So we have similar vitellogenesis, similar maturation, similar spawning. So in females, the probiotic is not so good to restore the reproductive dysfunction due to the bisphenol A treatment. A second case study was done always in zebrafish, but to evaluate the modulation, the negative effect of the microcystin LA. This microcystin is a toxin produced by cyanobacteria, and we know that during the climate change induce bloom of cyanobacteria, so induce an increase of the concentration of this toxin in the water. And we know that this toxin have negative effects on multiple organs, including the gonads. So we know that this toxin have negative effects on gonads, and this is the reason why the authors treated zebrafish with a probiotic to evaluate the possible role of mitigating these effects. And they performed the analysis only on females, and they obtained good results when they evaluated the vitellogenesis and the spawning. So in this case, the probiotic administration could help the females to recover the injuries due to the exposure to the toxin, mycotoxin. And the results done a lot of analysis, histological analysis, hormonal analysis. They done also a transcriptomic analysis by RNA-seq, and all the results they obtain good results. So in this case, the probiotic has a good role on the recovery of the reproduction. This is the last case study. The authors used also zebrafish for this study, and they treated zebrafish with PFBS, which is a persistent organic pollutant. Is an emerging organic pollutant, and we know that this pollutant may disrupt the reproduction of animals, interacting with the hypothalamus-hypophysis gonads axis, and reducing the sperm and the oocyte development and quality. So for this reason, the author exposed the zebrafish only with the PFBS and the co-exposition of PFBS with probiotic, and they obtained clear negative results. In this case, probiotic improved the damage due to this pollutant. So they analyzed the vitellogenesis and the spawning using several kinds of tools, by analyzing the reproductive index, by hormonal analysis, by qPCR analysis, and all the results clearly demonstrated that probiotic administration, the combination of probiotic and this pollutant, have a clear negative effects on female reproduction. So, I'm concluding. A lot of studies have addressed the efficacy of probiotic in female farmed species, both ornamental and commercial species. The majority of these studies highlighted the capacity of probiotic to improve the reproduction, to enhance, to interact with the brain hypothalamus-hypophysis gonads axis, and can improve both vitellogenesis, maturation, and finally spawning. The use of probiotic on reproduction could reduce the cost of hatcheries. The results obtained on tilapia demonstrated this. The use of probiotic could decrease the feed cost per unit, and consequently, the use of probiotic can lead to environmental sustainable aquaculture industry. A lot of work has been done there are almost 20 years that we are working on the effects of probiotic on reproduction. So a lot of years, a lot of work has been done, but we have still limited number of studies focused on male. We have different kinds of strain of probiotic used. We have different kind of time exposure of probiotics, so we don't have a clear protocol, but we have a lot of strains, we have a lot of protocol administration, so the situation is not so much clear right now, and we have a limited number of studies which have applied omics analysis. Most of the studies evaluated only macroscopic index. Only a few studies applied molecular biology analysis. By applying molecular biology analysis, we can obtain important information about the molecular mechanism. And so when we know the molecular mechanism by which the probiotic affect the reproduction, we can improve the protocol, the administration protocol of this probiotic. And finally, we totally lack studies on marine fish. So I finish. I thank you for your attention, and thank you.